In question number 33, they give us two functions, and they want us to find f open circle g of x. Remember, this notation is composition. This is f composed with g of x, which means take f of x and evaluate it at the function g. So the outermost function is going to be the function f, and what we're plugging into f is going to be g of x. Let me begin by just copying down the statement form for f. What does f tell us to do to an input? Well, it says take 6 times the square of your input and add 4 to it. This is essentially what the function f tells us to do. Well, what are we plugging into f? Well, we're plugging in the function g, which is 3x. So for my input into f, I'm putting g, which is 3x, which gives us this expression right here. We can reduce this. This is going to be 3 times 3x squared, which is 9x squared plus 4. 9 times 6x squared is going to be a 54x squared plus 4. So this is f composed with g of x. It's 54x squared plus 4. Let's take a look at number 34. Again, we have two functions. This time we're asked for g composed with f of x. This is g of f of x. The outermost function is the function g, and we're plugging f into g. So let me begin by writing out the statement form for g. What does g of x tell us to do to an input? Well, g of x says take your input and multiply it by negative 4. So g looks like this. It's negative 4 times input. What am I plugging into g? Well, I'm plugging in f of x, which is 2x squared minus 3x. We can simplify this by distributing. This would be negative 8x squared plus 12x. And so that's our expression for g composed with f of x. It's negative 8x squared plus 12x. In question 35, they want us to find the value of g composed with f of 3. This is by definition g of f of 3. If we do what's on the inside first, we would first have to find the value for f of 3. Let's maybe work that over here off to the side. F of 3 would be equal to 3 squared minus 8, which is 9 minus 8, which is equal to 1. So the value for f of 3 is 1. And we're taking that and we're plugging that into g. So now what we would have to do would be to do g of 1. Let me also kind of do that over here off to the side. G of 1 is equal to 1 squared plus 11, which should work out to be 12. So what is the overall value for g of f of 3? Well, it's equal to 12. Take a look at question number 36. Question number 36 asks us whether or not the function is one-to-one or whether it has an inverse. Here, if we look at the function presented in 36, this function fails the horizontal line test. The horizontal line test says that if there's any horizontal line that intersects the graph in more than one point, then the function is not one-to-one. So it's not one-to-one by the horizontal line test, and because it's not one-to-one, it does not have an inverse. We know that it's only the one-to-one functions that have a proper inverse. So the graph displayed in number 36 would not have an inverse. Okay. In question 37, they give us this function, and they ask us to find f inverse of x. To do this, there's 3 steps that are involved. The first step is we want to revert back to the old school y notation. So instead of calling it f of x equals, we're going to call it y equals. This is 5x minus 1 over 4. The next thing we're going to do is we're going to interchange the x's and the y's. So everywhere you see a y, put an x. Everywhere you see an x, put a y. And now the very last thing we need to do is we need to resolve this equation to get y by itself. To do that, I can begin by multiplying both sides by 4 to get rid of the fraction. So we have 4x equals 5y minus 1. To get y by itself, we would now add 1 to both sides. This would say that 4x plus 1 equals to 5y. And then just divide everything by 5. So we would get y equals 4x plus 1 divided by 5. And the moment we have resolved this for y, that actually is our inverse. So f inverse of x is equal to 4x plus 1 divided by 5.